Top 30 Civil Engineer Job Interview Questions and Answers. Preparing for a civil engineering job interview requires more than knowing technical concepts. Employers want to understand your engineering knowledge, problem-solving ability, project experience, safety awareness, communication skills, and ability to work under pressure. In this guide, you will find 30 commonly asked civil engineer interview questions with professional sample answers. These questions cover structural engineering, construction management, surveying, materials, estimation, safety, quality control, AutoCAD, project planning, and teamwork. Use these answers as a foundation, then personalize them with your education, practical experience, projects, achievements, and career goals to make your responses confident and authentic. 1. Tell me about yourself. I am a civil engineering professional with strong knowledge of construction, structural principles, surveying, materials, estimation, and project coordination. During my studies and practical experience, I developed skills in analyzing drawings, preparing quantities, monitoring site activities, and following safety procedures. I am comfortable using engineering software and communicating with contractors, engineers, and workers. I consider myself responsible, detail-oriented, and willing to learn. My goal is to contribute my technical knowledge to successful projects while continuously improving my engineering and management abilities. 2. Why did you choose civil engineering as a career? I chose civil engineering because I enjoy designing, planning, and constructing projects that provide practical benefits to society. Civil engineering allows me to combine mathematics, science, creativity, and problem-solving to create roads, buildings, bridges, and infrastructure. I also appreciate that every project presents different technical challenges and opportunities to learn. This profession gives me the satisfaction of seeing a project develop from drawings into a completed structure. I believe my interest in construction and technical problem-solving makes civil engineering a suitable long-term career for me. 3. What are your main strengths as a civil engineer? My main strengths are attention to detail, problem-solving, teamwork, and responsibility. I understand that small errors in measurements, drawings, quantities, or construction procedures can create serious project problems, so I carefully review my work. I also communicate effectively with team members and remain calm when unexpected issues arise. Another strength is my willingness to learn new technologies, software, and construction methods. I always try to balance technical requirements, project schedules, quality standards, safety procedures, and budget considerations while completing assigned responsibilities. 4. What is your experience with AutoCAD? I have experience using AutoCAD to prepare, modify, and review civil engineering drawings. I understand basic drafting principles, dimensions, layers, annotations, layouts, and drawing organization. I can work with architectural, structural, and site-related drawings and make necessary revisions according to engineering requirements. I also understand the importance of checking drawings carefully before construction begins because incorrect dimensions or details can create costly site problems. I am continuously improving my AutoCAD skills and can learn project-specific drafting standards and software requirements quickly when necessary. 5. How do you ensure quality on a construction site? I ensure quality by following approved drawings, specifications, method statements, inspection procedures, and applicable standards. Before work begins, I review requirements and confirm that materials, measurements, and construction methods are appropriate. During construction, I conduct regular inspections and coordinate with supervisors, contractors, and quality control personnel. I document problems and make sure corrective actions are completed before proceeding. I also believe prevention is better than correction, so I communicate potential quality issues early. Proper documentation, inspection, supervision, and teamwork are essential for maintaining consistent construction quality. 6. How do you handle construction site safety? Safety is one of my highest priorities on any construction project. I follow site safety policies, personal protective equipment requirements, risk assessments, toolbox meetings, and approved work procedures. Before starting activities, I identify possible hazards and ensure workers understand the necessary precautions. I also report unsafe conditions immediately and avoid allowing work to continue when serious risks exist. Good communication is essential because everyone on a construction site has a responsibility for safety. My approach is to prevent accidents through planning, awareness, supervision, training, and continuous monitoring. 7. What is concrete and what are its main components? Concrete is a construction material commonly used for foundations, columns, beams, slabs, pavements, and other structural elements. Its primary components are cement, fine aggregate, coarse aggregate, water, and, when required, chemical or mineral admixtures. Cement reacts with water through hydration and binds the aggregates together. The proportions of these materials significantly affect strength, workability, durability, and setting characteristics. As a civil engineer, I understand the importance of proper mix design, batching, placing, compaction, finishing, and curing to achieve the required concrete performance. 8. What is the difference between cement and concrete? Cement and concrete are different materials, although they are closely related. Cement is a binding material that reacts with water and helps hold other ingredients together. Concrete is a complete composite material made using cement, water, fine aggregate, coarse aggregate, and sometimes admixtures. Cement acts as the binder, while aggregates provide volume and structural stability. Understanding this difference is important when discussing construction materials, mix proportions, and quality requirements. Proper cement selection and concrete mix design are essential for achieving the required strength, durability, and workability. 9. What is surveying and why is it important? Surveying is the process of measuring and determining the positions, elevations, distances, and relationships of points on or near the Earth's surface. It is essential in civil engineering because accurate survey information is required for planning, designing, setting out, and constructing projects. Surveying helps establish boundaries, levels, alignments, coordinates, and reference points. Errors in surveying can affect foundations, roads, drainage systems, and structural positioning. Therefore, I believe careful measurements, appropriate instruments, accurate calculations, and verification are necessary to ensure construction work follows the approved design. 10. What is the purpose of a foundation? A foundation transfers the loads of a structure safely to the supporting soil or rock. Its purpose is to distribute structural loads, control settlement, maintain stability, and prevent excessive movement or failure. The appropriate foundation type depends on factors such as building loads, soil conditions, groundwater, site constraints, and structural requirements. Foundations may generally be shallow or deep depending on the project. As an engineer, I would review geotechnical information, structural drawings, and design requirements before selecting or supervising foundation construction to ensure adequate performance and safety. 11. What is the difference between a beam and a column? A beam and a column perform different structural functions. A beam is generally a horizontal structural member designed primarily to resist bending and shear caused by loads acting on it. A column is generally a vertical structural member designed primarily to carry compressive loads and transfer them toward the foundation. Both members are important components of structural systems and must be designed and constructed according to engineering requirements. Understanding their load paths, reinforcement details, connections, dimensions, and material properties is essential for maintaining structural stability and safety. 12. What is the difference between dead load and live load? Dead load is the permanent load carried by a structure, such as the weight of structural members, walls, floors, fixed equipment, and other permanently attached components. Live load is a variable load caused by occupants, furniture, movable equipment, vehicles, or temporary activities. Engineers consider both types when designing structural elements because they influence required strength and stability. Proper load assessment is important for safe structural design. I would always follow applicable design codes and project specifications when determining load values and applying them to engineering calculations. 13. How do you manage pressure and tight project deadlines? I manage pressure by organizing tasks according to priority, urgency, safety, and project impact. I first understand the required deliverables and identify activities that could affect other teams or the critical schedule. Then I create a practical plan, communicate deadlines clearly, and monitor progress regularly. If an unexpected problem occurs, I analyze its cause and discuss possible solutions with the relevant team members. I never compromise safety or essential quality requirements simply to meet a deadline. Effective planning and communication help me remain productive under pressure. 14. How do you handle disagreements with contractors? I handle disagreements professionally by focusing on facts, contract requirements, drawings, specifications, and project objectives rather than personal opinions. First, I listen carefully to understand the contractor's concern. Then, I review the relevant technical information and explain my position clearly. If necessary, I involve the project manager, consultant, or appropriate authority to reach a documented decision. My goal is always to resolve conflicts quickly while maintaining quality, safety, schedule, and contractual requirements. Professional communication and accurate documentation are important when dealing with construction disagreements. 15. What is your approach to project planning? My approach to project planning begins with understanding the scope, drawings, specifications, resources, schedule, budget, and major project risks. I identify required activities and their dependencies, then coordinate labor, materials, equipment, subcontractors, inspections, and approvals. I monitor progress against planned milestones and communicate delays as early as possible. I also consider safety and quality requirements during planning rather than treating them as separate activities. Good project planning helps reduce unexpected problems, improve resource utilization, control costs, and support timely completion while maintaining required engineering standards. 16. What is quantity estimation in civil engineering? Quantity estimation is the process of calculating the amount of materials, labor, and work required to complete a construction project. It may include quantities for concrete, reinforcement steel, masonry, excavation, plastering, flooring, earthwork, and other activities. Accurate estimation supports budgeting, procurement, scheduling, tender preparation, and cost control. I use drawings, specifications, dimensions, measurement rules, and appropriate calculation methods to prepare quantities. I also review calculations carefully because estimation errors can lead to material shortages, excessive purchasing, budget problems, and project delays. 17. What is a BOQ? BOQ stands for Bill of Quantities. It is a document that describes construction work items and their measured quantities, often including units and other information required for pricing and procurement. A BOQ helps contractors prepare bids and allows project teams to compare costs more systematically. It can also support cost control and payment evaluation during construction, depending on the contract arrangement. As a civil engineer, I understand that BOQ quantities should be prepared carefully from approved drawings, specifications, and measurement procedures to minimize errors and disputes. 18. How do you inspect construction materials? I inspect construction materials by checking their specifications, quantities, physical conditions, certificates, test reports, and compliance with approved project requirements. Depending on the material, inspection may include sampling and laboratory testing. For example, concrete ingredients, reinforcement steel, aggregates, bricks, and other materials may require specific quality checks before use. I also verify that delivered materials are stored correctly to prevent deterioration or contamination. If materials do not meet requirements, I report the issue and ensure they are properly identified, rejected, or approved through the appropriate procedure. 19. What is curing of concrete? Curing is the process of maintaining suitable moisture and temperature conditions in concrete after placement so that cement hydration can continue effectively. Proper curing helps concrete develop its intended strength and durability while reducing the risk of excessive shrinkage and cracking. Common curing methods include water curing, wet coverings, curing compounds, and other approved techniques. The appropriate method and duration depend on project requirements, concrete type, environmental conditions, and applicable standards. As a civil engineer, I understand that inadequate curing can negatively affect concrete performance even when the original mix is properly designed. 20. What causes cracks in concrete? Concrete cracks can occur for several reasons, including drying shrinkage, thermal movement, settlement, excessive loads, poor curing, improper reinforcement, construction defects, or foundation movement. Some cracks may be minor, while others can indicate serious structural or durability concerns. When cracks appear, I would first examine their location, width, pattern, depth, age, and likely cause, rather than immediately applying a repair. I would compare observations with drawings and project requirements and consult the responsible structural engineer when necessary. Correct diagnosis is essential before selecting an appropriate repair method. 21. How do you handle a design change during construction? When a design change occurs, I first confirm that the change has been properly authorized and documented. I review the revised drawings, specifications, quantities, schedule effects, safety implications, and material requirements. I then communicate the change clearly to the relevant site personnel and ensure outdated drawings are removed from active use. I also monitor implementation and document completed work. Design changes should never be based solely on verbal instructions when formal approval is required. Proper communication and documentation help prevent construction errors, disputes, rework, and unnecessary project costs. 22. What is your experience with structural drawings? I have experience reading and interpreting structural drawings to understand dimensions, levels, reinforcement details, sections, schedules, member locations, and construction requirements. I carefully compare structural drawings with architectural and other relevant drawings to identify potential coordination issues. Before construction, I check important details and clarify discrepancies through the appropriate engineering or project management channel. Accurate drawing interpretation is essential because site teams depend on drawings for execution. I understand that engineers must remain attentive to revisions, drawing numbers, dates, notes, and specifications throughout the project lifecycle. 23. How do you control construction costs? I help control construction costs through accurate quantity estimation, proper material planning, efficient resource utilization, waste reduction, progress monitoring, and timely identification of potential cost problems. I compare actual work and material usage with approved quantities and budgets where appropriate. I also coordinate procurement and construction activities to avoid unnecessary delays and rework. Quality control is another important part of cost management because defective work can require expensive repairs. My approach is to maintain a balance between cost, quality, safety schedule, and technical requirements rather than focusing only on the lowest initial cost. 24. What would you do if you discovered a construction error? If I discover a construction error, I would first assess the situation and immediately communicate it to the responsible supervisor or engineer. If the error creates a safety risk or could cause further damage, I would recommend stopping the affected activity until the issue is evaluated. I would review drawings, specifications, measurements, and site conditions to understand the cause. Then I would support the approved corrective action and document the resolution. I believe reporting mistakes quickly is better than hiding them because early action can reduce safety risks, rework, delays, and costs. 25. How do you prioritize tasks on a construction project? I prioritize tasks based on safety, critical path activities, project deadlines, dependencies, resource availability, and potential impact on other work. Safety-related issues always receive immediate attention. After that, I focus on activities that could delay subsequent operations or affect major milestones. I maintain communication with supervisors and team members so priorities remain clear when project conditions change. I also review progress regularly because construction schedules can change quickly. Effective prioritization allows me to manage multiple responsibilities without losing attention to quality, technical requirements, or important deadlines. 26. What is the importance of soil testing? Soil testing provides information about the physical and engineering properties of soil at a construction site. It can help determine characteristics such as bearing capacity, density, moisture content, compaction, shear strength, and settlement behavior depending on the test performed. This information supports foundation selection, earthwork planning, pavement design, and other engineering decisions. Without adequate knowledge of site conditions, inappropriate design or construction decisions may create serious problems. I understand that soil investigation results should be reviewed carefully and incorporated into design and construction planning. 27. How do you work effectively with a multidisciplinary team? I work effectively with multidisciplinary teams by communicating clearly, respecting each professional's responsibilities, and focusing on shared project objectives. Civil engineering projects often involve structural engineers, architects, surveyors, mechanical and electrical teams, contractors, suppliers, and project managers. I make sure technical information is communicated accurately, and that important coordination issues are identified early. When disagreements occur, I focus on drawings, specifications, codes, and project requirements rather than personal preferences. Good teamwork reduces conflicts, prevents rework, improves coordination, and supports safer and more efficient project delivery. 28. What civil engineering software do you know? I am familiar with civil engineering software used for drafting, design, quantity work, planning, and project documentation, depending on project requirements. AutoCAD is particularly useful for preparing and reviewing technical drawings. I also understand the importance of learning software such as structural analysis, quantity estimation, scheduling, surveying, or building information modeling tools when required. My approach is not simply to know software commands, but to understand the engineering principles behind the work. I can adapt to new programs by practicing, following project standards, and learning from experienced team members. 29. Where do you see yourself in 5 years? In 5 years, I want to become a more experienced and dependable civil engineering professional with strong technical and project management capabilities. I hope to take greater responsibility for construction activities, quality control, planning, coordination, and problem solving. I also want to strengthen my knowledge of engineering standards, software, safety practices, and modern construction technologies. My goal is to contribute to larger and more complex projects while developing leadership skills. I want my career growth to come through consistent performance, continuous learning, professional development, and meaningful contributions to successful projects. 30. Why should we hire you as a civil engineer? You should hire me because I bring a strong commitment to engineering quality, safety, teamwork, and continuous learning. I understand the importance of following drawings, specifications, procedures, and project requirements while remaining practical when solving site problems. I am responsible, adaptable, detail-oriented, and willing to take ownership of my work. I also communicate professionally with different project stakeholders and understand the importance of meeting deadlines without compromising safety or quality. I would bring a positive attitude, technical curiosity, and strong commitment to contributing to your organization's successful projects. A successful civil engineering interview requires preparation across technical knowledge, construction practices, safety, quality control, project management, communication, and behavioral skills. The 30 questions above can help you practice clear and professional responses before your interview. Remember that strong candidates do not simply memorize answers. They connect their responses with real projects, academic work, internships, site experience, and measurable achievements. Review the questions regularly, practice speaking confidently, and research the employer and position carefully. With preparation, honesty, and a professional attitude, you can make a stronger impression and improve your chances of securing the civil engineering position.